pop-up, close it, cancel the pop-up. And then under Welcome to Collaboratory, you will see File and New Notebook.
राजेश जी एक बार रिपीट कर दीजिएगा.
Yeah, I'll do that, sir. Once, let me just put the window also, so that I can paste the code snippets for people who are not. Just a second, sir. So all of you go to Google Collaboratory. Once you have gone into Google Collaboratory, you will see a pop-up. Okay, that pop-up, just close the pop-up, and below Welcome to Collaboratory, you will see something called File. See here. Once you close the pop-up, initially when you go to Google Collaboratory, there will be a pop-up on the screen. Just cancel it. Once you cancel it, below Welcome to Collaboratory, click on File and New Notebook. Click on File and New Notebook. So all of you open. Can you please confirm in the chat window or orally that you have opened this Google Collaboratory?
Yes, yes.
Okay. So Google Collaboratory is a fully equipped version of Python provided by Google for doing machine learning research, deep learning research, any type of AI-based research. Artificial intelligence-based research also can be done using this Google Collaboratory, where it provided GPUs as well as TPUs, tensor processing units and graphical processing units for the people to experiment with their models. It's a completely free environment. The only requirement is you need to have a little bit high-speed internet because it's a cloud-based environment. Minimum of 10 Mbps is what generally Google Colab requires, but it will work at 4 Mbps or 2 Mbps. Only it will take time to execute the commands. If you have 100 Mbps or 1 gigabyte line, it is very, very fast. Very, very fast. So this is a cloud-based environment which is given by Google free of cost for the people to learn AI, machine learning, and deep learning. Okay, so all of you can see my screen clearly, right? Because my screen is already 200% zoom. Okay?
Yes, yes.
So import the package. Import pandas as PD. Import numpy as NP, import matplotlib.pyplot as PLT, and the third one is the line to see the graph immediately after the cell, matplotlib in line. So whenever you start working with Python for any purpose, be it machine learning, deep learning, or regular statistical modeling, or anything, you need to import these three packages. And the last line is to see the graph immediately after the cell. Now, you can either press on this black and white triangle, or the keyboard shortcut is Shift plus Enter. Every cell must be run. Your cursor can be anywhere in the cell. It should be there anywhere on the cell, and press Shift plus Enter is the keyboard shortcut. Okay, as long as it is running, you can see a circle going on. Once the command is run, you will see a number. You will see a number. The moment the command is executed, you will see a number.
For execution, what we have to do?
Shift plus enter. Or you can click on this black and white triangle. This is the run this thing, or shift plus enter. So let me introduce what is this pandas. Pandas is for data frame based operations. Data frame based operations. That means import, export, your concat, your basic plotting, all these things are there in pandas. Pandas is a data frame based operation system. Pandas is a data frame based database operations system. Okay, so data frame by default, columns will be variables, and rows will be observations. Now, participants, please, if your typing speed is not good, please do not type. I will give you the same notebook with the notes as soon as the session is done. If you are comfortable, you can write. Otherwise, whatever I'm typing after the hashtag is all notes. After the hashtag, what I'm typing it as notes. If you want, you can type, or I will share anyway the notebook along with the notes after the session is done. Okay. So pandas and data frames. The data frames means by default variables will be in columns, rows will be observations. We simply call it as in Microsoft Excel a table. In Excel we call it as data table. In Microsoft we use this word data table. So pandas is for that. Then comes your matplotlib. Matplotlib.pyplot is a data visualization software exclusively for data visualization for ML, DL, deep learning, and AI. There are a lot of complicated graphs which we use, heat maps. We use a lot of types of visualizations. All the things is there in Matplotlib. Okay.
Okay. I'll be showing you demonstration also.
Yeah, some voice is coming. Yeah. Now, the third package is NumPy. NumPy is for array-based operations. This is the basic data structure of Python. NumPy arrays. NumPy arrays, they look like lists. So NumPy arrays are the basic data structure of Python. So whenever you compute anything, the output will be a set of arrays. A set of arrays will come as outputs. So NumPy is a very, very important package. And there are sub-packages in NumPy. There are sub-packages in NumPy which are very essential. One is scipy.stats. This is for statistic, all types of statistics, statistics-based modeling we can do using scipy.stats. You can have stats models. This is for time series or IoT-based data analysis. So IoT data is basically a time series data. You have stats models, which is a sub-package of NumPy. Once you import NumPy, these packages are automatically imported. Then the most important package, scikit-learn. Scikit-learn, short form is sklearn, is the package for machine learning and deep learning in Python. All the required functions for pre-processing, for model building, everything is there in sklearn. Scikit-learn is the fundamental package that is within the NumPy package, which is there exclusively for machine learning. sklearn, scikit-learn is the package. Everything you need for machine learning is there here. See, classification models, regression models, clustering models, dimensionality reduction, model selection, pre-processing. So all those things which you need across the machine learning development and machine learning usage, you can see all those functions within this sklearn package. Pre-processing, building a classification models, regression models. You click on classification models, you can see all the classification models. There are many classification models which are there within the Python with various functions and utilities that are there. See here you have neural networks, supervised learning model. So sklearn is again a part of your NumPy package. So once you import pandas, NumPy and Matplotlib, you have done majority of importing which is there. Okay. Now, if you are looking at deep learning, there are certain exclusive packages within Python, within the Python environment that have been separated and given for deep learning. The first package is import Keras. Import Keras and also import Tensorflow. Tensorflow as TF. So basically Keras and Tensorflow are integrated. Both should automatically, if you import Keras, Tensorflow will also be automatically imported. But for the time being, we are just looking at to show that Keras has TensorFlow inbuilt. And yesterday I have shown you the difference between a tensor and a normal things, right? All of you understood the concept of tensors? Multi-dimensional arrays. Tensors are multi-dimensional arrays. They store data in multi-dimensional matter. So multi-dimensional arrays are very important for fast processing or parallel processing, thereby reducing the time required for computing. Okay. So all of you are here. All of you imported this thing. I think you guys did not work on fashion MNIST, right? You worked on handwritten digits MNIST, if I am not wrong. Can participants confirm you worked on handwritten digits MNIST, right? Handwritten digits. Can anybody confirm me? Amit sir? I think you have used handwritten digits.
Yes. Handwritten,
Yeah.
that one example is given.
What fashion MNIST you have not used? Fashion.
No.
Okay. We have used fashion MNIST. Okay. So since you already used handwritten digits, so this is Google Collaborate, sir. Shankar sir, Google Collaboratory. I am using Google Collaboratory. All right. Fashion underscore MNIST is equal to tf dot keras dot datasets dot fashion underscore its prompts. Auto prompt is there. Use auto prompt. Okay. Once you type the first three letters, you will get it. This is the data set which you are going to import. I am pasting the command for people in the chat window. You can copy the command from chat window if you want. Okay. So fashion underscore MNIST is equal to tf.keras.datasets.fashion underscore MNIST. See, one of the important problems in deep learning is getting the data. Getting data is very, very difficult task. That's what we have seen. So what happened is a lot of universities and are creating data sets for people to do research in deep learning. One such data set which was created was fashion MNIST. Okay, I will show you what all is there in this fashion MNIST. Okay, so all of you can look at the things. Import Keras, TensorFlow, TF, Pandas, everything is clear, right? Okay. Now you will create train and test. Train underscore images, comma, test, train underscore labels, comma, again brackets open, test underscore images, comma, test underscore labels is equal to fashion MNIST underscore MNIST dot, or let me move it down so that everybody can see, dot, you can type in straight line, load underscore data. I am typing in 2 lines so that people can see it, but you can type in 1 line. So train underscore images, comma, train underscore labels, comma, test underscore images, comma, test underscore labels is equal to fashion underscore MNIST dot load underscore data. Oh, it's not taking like this, so I have to move it up onto it. So the command is this train test images. I will paste the command in the chat window so that everybody can understand, because the note part is not working properly. That way it is easy for people to understand. So I pasted the command in the thing. This will import the data, fashion MNIST data, from the storage of Google APIs. Okay. So all of you could import the data. Can people confirm?
Yes.
Okay. Now let us understand the data. What we are looking at. Print train underscore images dot shape. Similarly, print test underscore images dot shape. So let us understand what is the data type we are dealing with. So the data is 60,000 images in train data with 28 by 28 size, and 10,000 images in test data, again 28 by 28 size. 28 by 28 is a pixel size, 28 into 28 or 32 into 32. So 28 into 28 is 784. The size is 784 thing. So you can see the size and shape of your train and test data. Train data and test data dot shape will give you the number of rows followed by the type of data. The first is number of rows. 60,000 rows of data is there. Similarly, how many types of labels? Also, we need to have equal number of labels, right? Print length of train underscore labels. Similarly, print length of test underscore labels. Okay. So we are looking at the labels. We have 60,000 labels and 10,000 labels. All the images have been labeled. All the images have been labeled. Okay, there are no missing data or no missing labels. All the images have been labeled.
Sir,
okay.
Sir, please paste the command whatever you imported. Before lines import pandas and PD import numpy and np. Please paste that command in the checkbox.
Okay, so right, so let us see what are the data, what is the type of data we are dealing with. PLT dot figure brackets, PLT dot IM show, image show, PLT dot image show, open bracket, train underscore images, square bracket. Let us see 100th image. What is the 100th image? PLT dot color brackets, sorry, color bar. PLT dot color bar brackets, PLT dot grid in brackets false. We don't want the grid. PLT dot show brackets. So this is the 100th image, the handbag image. 100th image is the handbag image. 100th image is the handbag image. Sorry.
Sir, go on printing the chat box also. The print command, the prints command, you print command,
Okay.
so that we can visualize.
I'll put everything in the chat window, sir. No problem. So I'll put each and every command, sir. So see here, the 100th image is of a handbag. plt.figure, plt.imshow. Suppose we want to see what is the 10,500 image. The 10,500th image is of, I think, a gown. This is a gown. This is a gown. So these are the images that are there in our data. So you can see the PLT is your Matplotlib. So Matplotlib will help you to find all the relevant color related, all the pictures related thing. The difference is, sir, the space, the speed, and the see. First thing is Matlab is paid. Is Matlab free? Did you get Matlab free of cost? Anybody in the last 3 days?
No.
What about Python? Absolutely free. Zero cost and zero licensing. UGC and ACT has clearly mandated universities to use Python and R. Not to buy any software, be it Matlab, be it SPSS, be it SAS, or your Veka also is now paid. Veka is also, there are free versions available, but Veka is also becoming paid version. The biggest difference is Matlab is paid, Python is absolutely free and zero cost. Second difference is Matlab is slower because it uses matrix-based calculations. Python is faster because it uses TensorFlow-based calculations. Third difference is Python is available for production in production servers. Directly, you can implement them in your servers. The models can be implemented in large-scale servers, clusters, anything. Matlab does not have that functionality. So Matlab is only for experimentation and classroom-based teaching and all. You cannot implement Matlab on productions, commercial productions. Python is implementable on commercial productions, which is being used by Amazon, Netflix, Microsoft, everything. So Python and Matlab are uncomparable. In fact, you cannot compare Matlab with R also. R also, there is a slight difference between R and Python because our community to somehow slowed down in making it large-scale computing, this thing, but they are now doing it. Python is now for large-scale computing. It can work with any terabytes of data also. Their Python has been created in such a manner. It works with Hadoop seamlessly. R also works with Hadoop seamlessly. Matlab, I doubt. Okay. Now, let us see some more images, how we can see a little bit of more images. I have just shown you the single image thing. So let us see the more images. So plt.figure in bracket, pick size. Pick
Rajesh,
size.
sir.
Yes, sir.
Good morning, sir. Sir, what is the importance of this color bar which we have plotted along with the image?
That is because the images are RGB. During the course of things, remember there is a 28 by 20, 28 comma 28 comma 1. 1 means grayscale. No. 28 comma 28 comma 3 will be your RGB.
That I understood, sir. Why do we use this color bar? What is the importance of this color bar?
So we have converted the grayscale into color bar. The data is grayscale images.
Okay.
The original data is grayscale. To see the edges properly, we are using color bar.
Yes, sir. Thank you.
For I in range 25 colon plt dot subplot in bracket 5 comma 5 comma I plus 1 PLT dot subplot 5 comma 5. That means we want 5 images in 5 rows. I plus 1. PLT dot xfix. Xfix square null brackets. PLT. Sorry. PLT dot ytix. Y-axis. X-tix is your x-axis. Y-tix is your y-axis. PLT dot grid false. You don't want a grid here. PLT dot imshow. PLT dot image show. Imshow is for image show. Open bracket. Train underscore images square bracket I comma CMap. Color map is PLT dot CM dot binary. PLT dot X label class underscore names square bracket train underscore labels square bracket I. Okay, so and then come out of the loop and say PLT dot show. Oh, class underscore names is not defined. Okay, no issues. See, these are the actual images. These are the actual images which we see. Let me paste the code so that everybody can use it.
Please paste the script in the chat box.
I have already done, sir. I have already done. Please take it from there. Okay, so all of you got this. Just make sure the indentation is properly done, because once I paste in the chart window, I think indentation will go off. The for loop has to have indentation like this, and the PLT show should be outside the image. All right, all of you got this? Okay, indentation is okay. Okay, sir, no problem. Then you are perfectly set. Yes. So all of you can see the images, right? These are the actual images. So to color them, you have to add color. PLT.color bar. Otherwise, you can see the images like this: T-shirt, shoes, sneakers, ladies' heels, gowns, lot of images are there. These are the first 25 images which I have printed. Okay, first 25 images which I have printed. Now, like I told you yesterday also, one of the important thing is that data must be normalized. Normalization must be done. Normalization must be done. Normalization of data must be done. Particularly in image processing. Done for image processing. Okay. So normalization of data must be done for image processing. Okay. So if you look at this thing, whatever normalization, yesterday I have given you the formula. The normalization, normalize is also called as min-max scalar. It is also called as min-max scalar. The other is standard scalar. For image processing, the best fit scalar is min-max scalar. Or yes, to save memory. Perfectly right. To reduce the images, to save the memory. Absolutely right, Shankar sir is there. So what is the formula? X minus X min divided by X max minus X min. Okay. So this is what the formula is. X minus X min divided by X max minus X min. Now look at our min of train underscore images. Okay. Okay, sorry. It's not giving. So let me just, I'll give you the code for finding out the lowest value. Train the underscore images is equal to train underscore images divided by 255. Test underscore images is equal to test underscore images divided by 255. Now, can anybody tell me why 255?
Because it is grayscale and that varies from 0 to 255.
Grayscale lies between 0 and
0 to 255.
0 to 255. Now, if you look at this thing, the grayscales lie between 0 to 255. See here, train underscore images dot min. Min is 0. Let me print it so that I can do the command. Similarly, print train underscore images dot max. Max is 1. Because we have already normalized it. Nah? So what we did was, initially there the minimum was 0 and 21. Since we have normalized, all the values have become between 0 and 1. If you are looking at original data, before I run the, you guys don't do it, just let me do it one more time so that people can understand the concept of 0 and 25. Please, you guys don't do it. I am just doing it to understand that concept. So, if I print the actual images, they are like this. Minimum is 0, maximum is 255. Now, once I normalize it, Once I normalize it, it will become, all the values will become from between 0 and 1. Like Shankar Rao sir said, to save memory. Absolutely right, 0 to 1. Now all the values have been converted to 0 and 1. So a lot of people ask why 255, because as sir is also saying, grayscale related one. Now let us build a simplistic neural network. Build a simple neural network. I want to build a simple neural network. A simple neural network without any convolution or anything. Let us do a simple neural network on our data. I'm just doing a simplistic neural network with say 128 layers, 128 neurons in first hidden layer. So that is the simplistic thing we can do. Now, model is equal to tf.keras.sequential. See, sequential is important because layers are sequential. Layers are sequential. So we have to give sequential as the keyword. Model is equal to tf.keras.sequential, open round brackets. Within round brackets, we are going to give multiple arguments. So that is why we are giving square brackets and press enter. So, sorry, took fashion MNS directly. Press enter. Okay. tf.keras sequential. Now, tf.keras dot layers dot flatten comma input underscore shape is equal to 28 comma 28. So we are giving an input shape of 28 and 28. We are just flattening it out. Flattening it out means you are converting all into a single vector. The flattening, we are directly flattening out. We are converting it into a single layer. Comma tf.keras.layers.dense. Now the keyword dense is very important here. Dense is where the actual neural network is being built. So dense is your actual neural network. So I am defining 128 neurons, comma. Along with neurons, you have to define the activation. The preferred activation for image processing is ReLU, comma, and tf.keras.layers.dense. This is your output layer. The output layer should have 10. The output layer should have 10 to predict. The output layer, since we have to predict, we are predicting it as so 10 predictions will come. 10 probability values will come. So I am defining a single layer network, which is a single layer network with 128 neurons. With 128 neurons. It's a single network with 128 neurons. So let me run it. I'll paste the code in the chat window. We have built the model. This is the definition of the model which we are building. Sequential, na? See, neural networks are sequentials. Neural networks are sequential, one layer after one layer. So that is what sequential is all about. Sequential means one layer after the other. They are not one on top of another. It is one after the another. That is why the word sequential. Now we will compile the model. Model.compile. Model.compile. First we have to specify the optimizer. Can anybody tell me what does optimizers do? Can anybody tell me what is the role of optimizer? Loss is equal to tf.keras dot losses dot sparse categorical cross entropy open bracket from underscore logits is equal to true. Okay, and then comma, we will give the next argument, comma, metrics is equal to square bracket single quote accuracy. For all classification problems, metric is the accuracy. Matrix is the accuracy. You are compiling the model here. I'm pasting the code in the chat window. See, optimizers play a very important role in what we call deep learning and machine learning. Optimizers are very important, particularly within the Keras. We have many optimizers. There are many optimizers available here. One is your gradient optimizer, Adam. See, these are the optimizers we have. Stochastic gradient, RMS prop, Adam, ADA delta, ADA grad, ADA max, Adam, FTRM. So we have used Adam optimization. It is a stochastic gradient descent method that is based on adaptive estimation of first order and second order moments. And you can see the reference for the paper, which is given here. So optimizer is a gradient descent method or weight reduction method. By default, the weight reduction method in Adam is 0.001. By default, the learning rate is 001. So we are going with the basic optimization. Okay. So this also helps you to save the memory. This also helps you to save the memory. Now we have defined our model. We have first defined our layers. Then we have also compiled the model with the optimizer and the loss and the metric. Now we will fit the model. Model.fit, open bracket, train underscore images, comma, train underscore labels, comma, epochs is equal to 10. I am giving 10 epochs. And what is an epoch? Did you guys discuss epoch? One complete cycle. Epoch represents one complete cycle of what we call feed forward and backward propagation. So this is what we are trying to do. See how fast it is working in Google Colab. It's done already. I don't think this was that fast in Matlab. Agreed or not?
Yes, yes.
Yes, Matlab is very slow.
This is the advantage of Python. That is why people are running after Python, because now you can see here at epoch 10, the accuracy and loss. See, the accuracy is around, I think you guys can see it clearly. What is the accuracy of the final step?
0.9.
Not 0.9. It will be some
90%.
It is only 0.9, huh?
Yeah.
No.
No.
0.9.
91.11%.
Yeah, 0.911. So initially it started with an accuracy of 82%. First by epoch it is 82%. By end of 10th epoch it went up to 91%. Now if you want, you can increase the epochs and see if it increases. So I will make it 20. Since it is running fast, let us make it 20 and see how the accuracy will improve or not. By adding epochs, can you improve the accuracy or not? See, it's running in seconds. It is very fast because tensors are very, very fast. Very, very fast, and they're running in seconds. I for 4 years back, when I was running these models, it used to take 1 hour. It was like hell. Then came the tensors and the Google launched everything free of cost. It became very, very fast process. And this collaborator is even faster. Only thing is you need to have a little bit of high-speed internet. It works wonders. See, 3 seconds. That means 1 minute it ran 20 epochs. Within 1 minute it ran 20 epochs, and the accuracy increased, see, to 94.71. It started with, I think, 91% accuracy. Why it changes? Because I did not set the seed. I did not set the seed, so the accuracy is bumping, or the accuracy is increasing or decreasing because I did not set the seed. If we have set the seed, we will get the same. Okay, see how the accuracy is there. Now, to check whether the model is good enough or not, we have to test it on our test data, right? So we already have some test data. So now let us try the test data, how the test data is impacted. Jupyter Notebook is again native CPU based one, sir, Shankar Rao sir. Google Collaboratory is a cloud based environment. You need to have internet. For Jupyter Notebook, you don't need. This is the same Jupyter Notebook. Google Collaboratory also uses Jupyter Notebook. This is a Jupyter Notebook, which I am using is a Jupyter Notebook. You can see here, .ipynb. Okay. Test underscore loss, comma, test underscore accuracy is equal to model dot evaluate. Model dot evaluate test underscore images, comma, test underscore labels. Test underscore labels. So model dot evaluate test images and test labels. Run. It run.
Please
So-
paste the code.
Yeah, I'll paste the code. Test underscore loss, comma, print test underscore accuracy. See, 88% accuracy on test data. I think we are having certain overfitting problem here because original model gave an accuracy of 94%. Test data is giving us 88.4. That might be a overfitting problem. Let me just see if anything changes. So 88.41 is the accuracy. Control C. So I pasted the evaluation model also on your chat window. So this is the simplistic neural network. This is simplistic neural network with one layer and 128 neurons per layer. Very simplistic neural network which we have built.
Sir, on
Yes,
my
please.
machine, the accuracy is different. Similarly, the accuracy
Because
varies from-
random weights, your weights will be different, my weights will be different, sir.
Okay, sir. Okay, sir. Thank you.
Random weight generation. Yesterday I said, no, sir, no two people will have until unless I set a seed. The np.random.seed, if I set it, everybody will get the same output. Otherwise, each person will get a different output, right? All of you can see marginal differences in the accuracies.
Yes, sir.
Because random weight generation, the fundamental of neural network is the weights are randomly generated. You don't have any control on those random generations. So that is why there will be slight difference, not a huge difference or very big difference. It's a marginal difference. You will see. Any doubts? Till now, we have completed one simple neural network model.
Sir, this verbo stands for, why have you used verbose equals to 2?
See here, we want the two values also here. See, these two values will be revealed. Otherwise, you will not know what is happening.
Okay,
Verbose
sir.
means this, which is running is verbose. You can know what is happening, what step is happening, what is the process it's doing. That will be shown in verbose. If you say verbose is equal to 0, it will not show, but it will keep on running. You will not know. By seeing the verbose, we can see that the model is running and there is something happening.
Okay, sir. Thank you so much.
Okay. Yeah. Any other doubts, participants? All of you able to run, right? No issues for anybody? Can I move forward?
Yes, sir.
Yeah. All right. Now we will get into our convolutional neural network. Convolutional CONVO, right? convolutional neural networks, also called as CNN. This is the most preferred network for image processing. This is most preferred network for image processing. Okay, a CNN will have what? It will have three. Basically, it has three parts. What are the three parts? Can anybody say? I think you have been going through this CNN for long. There are three parts. First one is a convolution layer. The first one is a convolution layer. The convolution layer will source the image, and it will do tasks like blurring, rotation, or sharpening, or noise detection, edge detection, etc. So it is all about pre-processing related things. This is all about pre-processing related things. This is the first layer within the convolution network. A lot of people think the first layer is the neural network. No, first layer is not the neural network. First layer is the image processing layer. The second is the pooling layer. What does pooling layer do? It reduces the image dimensionality. Primarily, pooling layer is reducing image dimensionality without losing important features and patterns. That is the job of pooling layer. And the most important layer is max pooling. We use max pooling as one of the most important pooling method. There is average pooling also, but max pooling has this. Even for convolution, we use convolution either 2D or 3D. Preferably, we use convolution 2D, two-dimensional. So pooling layer, generally we use max pooling. Now comes the third part, which is the fully connected layer part. This is the fully connected layer, where the dense layer in which the results of previous two layers are fed. Layers are fed into neurons to generate prediction. So the three important components of the convolution layer. The first one is convolution neural network. First one is convolution layer that does tasks on the images. Pooling rays reduces the dimensionality without losing information. And the third is the fully connected layer, which is nothing but the neural network layer. So these are the three important components of a convolution neural network. Okay. Now we will build a convolution neural network on the same fashion MNIST data set, on which we have built what we call a simple neural network, single layer network of 128 neurons. Okay. From Keras, import sequential. From Keras, import sequential. From Keras dot layers, import the first one, convolution 2D, comma, max pooling 2D, comma, batch normalization. From Keras dot layers, import convolution 2D, max pooling 2D, and the normalization thing. From Keras dot layers, import the important components of neural network, which is dense. Dense is the neural network hidden layer. Dropout. Dropout is also very essential. Drop out those neurons which are not effective. Flatten. You have to ultimately flatten these into a vector to be fed to a neural network. And activation. Activation. So these are the important things which we require for creating our own neural network. I'm pasting them in the chat window. You can take it from here. So for building our convolution network, we need these functions to be imported. Sequential function, convolution 2D function, max pooling function, normalization function. And then when you're building the neural network layers, you need to have this dense, flatten. Dropout you can use whether with convolution 2D as well as max 2D. Flattening is the final thing which you need to do to convert the data into a single vector that can be fed into the neural network. Okay? Okay. Now, let us redefine our data. X underscore train, open bracket, round bracket, X underscore train, comma, Y underscore train, comma, X underscore test, comma, Y underscore test is equal to fashion underscore MNIST dot load underscore data. So earlier in the previous model, I have used train images and train labels. Here we are using train and test as the names. So earlier I have used train and images and test images. Here I am naming it as X train and Y train. So that because we have to do reshaping of the data here. So that is why I am using a different set of names. Earlier, we did not do any reshaping. We have just flattened it and put it into our neural network. But for a convolution neural network, we have to convert the images into, we have to reshape the images into a format that can be run by the convolution 2D functions. Okay, that is why I am renaming my input data from train images and train labels. Yes, sir. Yes, ma'am. Madam, 50,000 images, test is 10,000 images out of 60,000. See, 1 second. See here, 60,000 and 10,000. You can alter it, ma'am. But again, you have to write a loop. Yes, you can do. You can. Yes, you can do. You can do. Huh. So what you can do is, yeah. Okay, so what madam is asking, she want to do her own, right? So what we can do is first get the data as fashion underscore MNIST dot load underscore data. So let us look at the shape of the data. Data dot shape. Oh, tuple has no attribute shape. Okay. Okay, the data is in this array format. Okay. Now, from sklearn dot pre-processing, import train underscore test. What is it? Sorry, from sklearn dot model underscore selection. Model underscore selection, import train test split. Train test split. Okay. So we can split our train and test data using this train test split. So you can see this is part of your what you call Python sklearn. X underscore train. Let me give one more thing. Don't want to dip. So X underscore train 2, comma. Both the test. X underscore test 2, comma. Y underscore train 2, comma. Y underscore test 2 is equal to train underscore test underscore split, open bracket, data, comma, test underscore size. Is equal to test underscore size only, right? Or what? Test underscore size is equal to, you can give the test data size, let us say 0.30, comma. And if you want random selection, you have to add random underscore state is equal to 1, 2, 3 or something you can add. Random underscore state is equal to 1, 2, 3. That means you're setting a seed here. That means it randomly splits the data and it will also not enough values to unpack expected 4 got 2. Let me remove the random state. So let us see if I can run without random state. Actually, I don't have the train test split. It's not working. Here it is there. X underscore train X comma Y. Test size is equal to 0.2. Okay. I'll give you the code, ma'am. Just give me some time because it's not working here. So I'm just making some mistakes. So I'll give you the thing later. Okay. You can do it, but actually, I think you have to run a loop. That is the problem because it is in the form of a tuple. So tuples are a little bit difficult to handle. I'll send you the thing. That's not a problem. Let me not waste the time. Okay. So we have created the shape. Now let us reshape the data. Image underscore rows, comma, image underscore calls is equal to 28 comma 28. Our image has 28 and 28 size. Okay. So x underscore train is equal to x underscore train dot reshape, open bracket, x underscore train dot shape, square bracket 0, comma, image underscore rows, comma, image underscore calls, comma, 1. So 28 comma 28 comma 1. X underscore test is equal to x underscore test dot reshape, in bracket, x underscore test dot shape, square bracket 0, first column, 0 comma, image underscore rows, comma, image underscore calls, comma 1. So we are trying to reshape the data, which is in the form of 28 28 comma 1, and we will also create an input shape. Input underscore shape is equal to image underscore rows, comma, image underscore calls, comma 1. So the input shape, we are reshaping the data, which is for your convolution neural networks. So I defined it wrong here. That's why it is not connected. Image underscore rows. So I've given the code in the things. So we are reshaping the data into 28 by 28, which is required for your convolution network, in the format which is required for your convolution. Now we will change the data type. X underscore train is equal to x underscore train dot as type. As type, we will further reduce the size to float 32. Similarly, x underscore test is equal to x underscore test dot as type. We are converting it into 32, float 32 to save the memory. Next, we will normalize. X underscore train is equal train divided is equal to 255. X underscore test divided is equal to 255. So we are reshaping and normalizing our data, also making it into a 32-byte data, not as a 64-bit data. I am copying and pasting the code. You can take it from the window.
Something went wrong while we are compiling. It is not being compiled.
Pardon, sir?
Something went wrong. In fact, the data, whatever data you have imported again, should I remove that?
No, I told you not to import, sir, but you have imported the data again.
Yeah, while you were explaining to madam, you imported the data again, na? Loaded the data fashion.
Even if you imported the data again, run the previous commands. It will automatically correct.
Okay. Somewhere I missed, sir.
No problem. So, sir, do one thing. Download the software called AnyDesk. I will help you out. AnyDesk is a software remote controlling. I can see what is the problem in your system and correct it immediately. Give me the 9-digit number. See, in this fashion MNIST, there are 10 classes. Actually, there are 10 levels of our fashion MNIST data set. Okay, there are 10 different types of things. So, these are the labels. See, 0 is your t-shirt. You can see here, there are 10 types of things starting from 0. First is t-shirt or top. First one is trouser, 2 is pullover, 3 is dress, 4 is coat, 5 is sandal, 6 is shirt, 7 is sneaker, 8 is bag, 9 is ankle boot. So there are 10 classes that need to be predicted. There are 10 classes that need to be predicted. These are the names: t-shirt or top, trouser, pullover, dress, coat, sandal, shirt, sneaker, and dress. These are the 10 classes which are there in our data. Okay. So num underscore classes is equal to 10. So number of predictive classes is 10. Now y underscore train is equal to Keras dot utils dot to underscore categorical y underscore train comma num underscore classes. Similarly, y underscore test is equal to Keras dot utils dot to underscore categorical y underscore test comma num underscore classes. So we are categorizing the classes. We are telling it is a categorical data. The data is from 0 to 9. Okay. What happened? Why num underscore class? Achha, I forgot to put the bracket. So we are categorizing. The labels are in 0 to 9. We are telling don't treat them as numbers, treat them as categorical variables. So to categorical is the data which we need to tell the algorithm to not to treat it as this one. All right. Shall we build the model? So model is equal to sequential brackets. Model is equal to sequential brackets. Model dot add. We are adding the first convolution layer, convolution 2D in bracket 32 comma kernel underscore size is equal to 3 comma 3 comma activation is equal to ReLU comma input underscore shape is equal to input underscore shape. Okay, we are giving the input shape, whatever we have defined as input shape. So I'll give you the complete model thing once I've completely framed. I will paste it in the chat window. You can take it from there. Then we will add the second convolution layer, model dot add open bracket convolution 2D open bracket. This time we will give 64 comma again kernel size is 3 comma 3 comma activation is equal to ReLU. Next model dot add model dot add convolution 2D convolution 2D open bracket 128 3, this is the filter. Activation is equal to ReLU activation. Now we will add the max pooling layer. Model dot add max pooling 2D open bracket pool underscore size is equal to 2 by 2. 2 by 2 filter. Max pooling filter is 2 by 2. Model dot add. We have to add dropout. Dropout in bracket 0.25. 25% dropout we are giving. Model dot add flatten. Brackets. Okay. Now we have flattened. Now here we will start the process of neural network. Model dot add dense. Dense is where the neural network will start. Dense with 128 neurons. 128 neurons, comma. Activation is equal to ReLU. Model dot add. We are again giving a dropout. Dropout in bracket 0.5. Last layer, model dot add. Now the last layer is very important here. It should have the number of classes. Activation is equal to activation in bracket pf dot nn dot softmax. Softmax for more than one prediction. If you want to have more than one prediction, you have to add softmax. So let us see the model summary. Model dot summary. You can see the summary of the model. Let me run it and I'll paste the code in the chat window. Oh, kernel underscore size, there is a mistake. K is small letter, F gave capital letter. So sometimes you make silly mistakes. ReLU also spelling mistake. Where is ReLU spelling mistake? Okay. So I'm pasting the model. You can go through the model. This is the model we have built. 3 convolution layers of 32, 64, and 128 with ReLU activation. Then we did the max pooling with 2 by 2 filter. We asked them to drop out 25% of neurons which are of no use, and then we flattened it. Then we started the neural network process with 128 neurons, activation ReLU, again dropout of 0.5. The last layer is a softmax layer with 10 predictions. The last layer is the softmax layer with 10 predictions. So this is the summary of the model which we have got. We are going to build this model. You can see the detailed summary. Okay. Now we need to compile. Model dot compile in bracket loss is equal to Keras dot losses dot categorical underscore cross entropy, comma, optimizer is equal to Keras dot optimizer dot. So we have taken ADA delta, comma, metrics, or metrics? Metric, right? Metrics. So what is the metrics? Metrics. Metrics is equal to square bracket single quote accuracy. So we have compiled the post model things. What is the problem? Could not. Okay, metrics is equal to accuracy. It is not able to find. One second. Let me check what is the error we are getting. It's not in this, so we have to go for another one. So we forgot the brackets for ADA delta. That is the problem. ADA delta matrix is equal to accuracy. That was the simple brackets missing is the problem. So we will compile the evaluation metrics. These are all your evaluation metrics. I'm pasting them in the chat window. Okay. So we have built the sequential model, then we have give the optimizer, we have give the loss, and we have give the metrics post fit. Now we can start building running the model. Model.fit x underscore train, comma, y underscore train, comma, batch underscore size is equal to 128, comma, epochs is equal to 20, comma, verbose is equal to 1, comma, validation underscore data, validation underscore data is equal to open bracket x underscore test, comma, y underscore test. Now let us run the model. So it will start building the model. Okay, it is taking time. So 1 second, we have to activate the GPU because it is taking a lot of time, 6 minutes time. So let us stop. I'm stopping the process. Okay. Now go to edit. Go to edit. Go to notebook settings. Click on hardware and GPU. Go to edit. Notebook settings, hardware accelerator is GPU, save. So what happens is you have to rerun the commands again from the data import. So let us just go to the top. Okay. First we have to import the packages. Or do one thing, go to runtime and click on run all. Go to runtime, click on run all. But before that, convert the editor setting to accelerator to GPU. Runtime, run all. It will run all the cells, no problem. It will just take seconds to run and then we will get the output. So all people have to go to edit, notebook settings, and in notebook settings, accelerator. Choose GPU. Edit, notebook settings, and then choose the accelerator as GPU. Choose the accelerator as GPU. Then it will start run all the commands because all the data has been considered as new input. So go to runtime and click on run all. Go to runtime and click on run all. Go to runtime and click on run all. See, now it is running in seconds. 5 seconds. So earlier it showed me 5 minutes. Now it is running in seconds.
So please explain again the process that you have done, GPU wala.
Click on edit. Below untitled notebook, you'll see edit. Click on edit. Go to notebook settings. It will open a window. It will say none. Click on the down arrow next to it and select GPU and click on save. Once you save it, all the will be considered as a new notebook. All the commands have to be run again. So go to runtime and click on run all. It will automatically run all the commands.
Okay, sir. Thank you.
Okay. This is the advantage of GPUs. See, 4 seconds. The first epoch showed me around 7 minutes to complete. That's why I stopped it and I moved to the GPU. See, it completed also. It ran with such a speed that it completed also.
Very good morning, sir. Sir, I want to ask that for this we required that we should have a GPU card on our system or not?
No required. No required. This is cloud environment, sir.
Okay, cloud environment only.
Yeah, this is all cloud environment. Collaboratory is all cloud environment. All the data and your files are saved in your Google Drive directly.
Okay, okay.
Everything is stored in Google Drive.
Okay. And
So
one more. Yeah, sir.
You don't
One more
have
thing I want to ask
system.
that we are using for some of the application we are using a TensorFlow. Okay.
Yeah.
Yeah. So sometime I have seen that TensorFlow is not working for the 32-bit system.
Huh. So
Yeah,
for Google
so-
Colab, it doesn't matter. Google Colab, it doesn't matter.
Okay, okay. Okay,
For
because
Google Colab, it's a cloud-based environment. Only requirement is you should have high-speed internet. That is the only requirement.
okay,
That
okay.
other than that thing, it will not use your CPU. It will not use your anything. It just is a cloud-based environment. Where see here, you can see the amount of RAM is given by them only. See,
Yeah,
it
yeah.
is giving you 13 GB RAM and disk size of 68.4.
58.4.
So this is cloud. Whether you are 32 GB or it's your 32 laptop, it doesn't matter. Only thing is internet, Google Chrome, and always use Google Chrome for Google Colab. If you try to use Internet Explorer, some of the functions will throw up error.
Yeah, yeah. Okay, 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 okay. Thank you, sir. Thank you.
No problem. See, let us see the score. What is the score we got? Or the actual model dot evaluate in bracket x underscore test comma y underscore test okay, print score square bracket 0. Score square bracket 0 is your loss. Print score square bracket 1, which is your accuracy. See, it is giving you 73% accuracy. So this convolution layer is not properly fed. We have to rework our convolution neural network because this is not giving our preferred accuracy. You see the value, the accuracy is only 69% or 86%. This is not giving us good accuracy. Now we have to improve our model to further increase our accuracy. All right, sir, shall we take a break and then continue? Amit sir?
Yes, yes. We can take a break of 10 minutes.
Yeah, we'll take a break of 10 minutes. Come back.
We will be back at 12:15.
Yes,
Okay.
Yes, sir.
Okay. Participants, we will be back at 12:15. Okay. Thank you.
Bhaskar sir.
Yes, sir. Prediction. I'm doing LSTM only. Let me fine tune this model first and then I'll jump into LSTM.
Sure,
This is a
sir.
recurrent
Thank you.
neural- okay?
Thank you.
We'll download the stock market data. I'll give my details, sir. No problem. I'll give my details at the end of the session, email and mobile number, everything, sir. So I'm starting, sir. Shall we start? Amit, sir?
Hello.
Yes, please.
Happy Targana.
So this is a refined version which I worked out after many trials. This is the version which finally gives us the good accuracy model. This is a where I have defined 1, 2, 3, 4 convolution layers with 32, 32, 24, and 64. And then I did one max pooling, dropout, flatten, and then the DINS 128, same 128 neurons in the layer. So this is the model which gives us good accuracy.
Sir, paste the code for updated model.
I have pasted, sir. Everything is there. CNN. See, updated model from here. Updated CNN model.
Yeah,
12:30 onwards, everything is there.
paste it, sir.
Yeah, I have pasted sir in the chat window. Acha, your chat window is not working. Okay. Let me you want me to repaste it?
Updated CNN, sir.
Updated CNN. I'm pasting it, sir. It's already there in the chat window. Updated
But it
CNN
is not-
model.
It
I
is
checked
not
the chat window.
It is not seen to me.
Refresh your chat window. Sir. Look at it. I pasted 2 times. So this model, see, test accuracy is 93%. On the model, the accuracy is 95%. So overfitting problem is not there. There is no overfitting problem because the test and the train accuracy are very close. No overfitting problem. As test, train validation and test accuracies closer. They are very close. They cannot be equal. They are very closer to one another. See, overfitting problem means, take for example, on training data, you get an accuracy of 95%. You run the model on test data, your accuracy reduces to 85% or 86%. That is called overfitting problem. Huge difference between accuracy of training data and test data. That is your overfitting problem. Typically more than 10. Okay, we want the accuracies of train model, test model, and validation model closer. In our case, train accuracy is around, the original train accuracy is on 95.15, test validation accuracy is 93.16, and then test accuracy is 93.16. So there is not much of a difference. The validation data and the, see here, the accuracy is 95.15 and the test accuracy is also 93.16. So both of them are closer to one another. Both of them are closer to one another. Then we do not have a problem called overfitting problem. If there is huge difference, then it is an overfitting problem. That happens in real time most of the times. People build a model, they get high accuracy, they think it's okay. No, you have to have similar closer accuracy on test data. In this case, there is no difference, sir. Shankar Rao sir, in this case, validation data and test data are same. In this case, validation data and test data are same. Generally, we break validation data from train data only. Generally, when you are breaking the data, we break the data into three if you want: train data, validation data, and test data. Validation data can also come from your train data only. That's a simple processor. You will find the code anywhere on internet, how to split the data into train, test, and validation. Or I will send it to you, the code, email it to you, no problem, sir. And one more ma'am also asked me, so I'll send you the code, how to split it into train, test, and all those things into one code. I have that code in my Windows laptop. I'll send it to you. So all of you got the outputs, right? Can we move forward?
Yes, sir.
Okay. Participants, can you confirm? Shall we move forward?
Yes, sir.
Yes, sir.
Yeah, double click on this untitled and you can give a name. You can rename the notebook by double clicking on that untitled on top and give a name. We close this old notebook and we'll open a new notebook. Okay, so just before that it will be untitled something. Double click on that and you can type your name there. .py is a file extension. Okay, close this. Let us open a new notebook. I'll open a new notebook. File, and I'll open a new notebook.
Just changing the name, will it be saved in the?
It is
cloud?
auto save, sir. You don't need to bother about. Jupyter Notebook has the function of auto saving.
Okay, sir. Thank you.
It auto saves everything. That's one biggest advantage in Jupyter Notebooks. You don't need to save. They keep on saving every 10 seconds. Auto saving will be there, and the notebook will be automatically saved in your Google Drive as a folder called Colab. It will automatically create a folder in your Google Drive called Colab Notebooks. In that you will see it. Or you can directly access through virtual also like this. By looking at your open notebook thing, click on file, open notebook. It will give you the list of notebooks which you have. See, you can find it here and then you can choose it from there. Yeah, I will share everything, sir. Shankar Rao, sir, I will share the notebook both in IPYNB format as well as in PDF format. As soon as the session is over, I will mail the IPYNB notebook as well as the PDF file of the same notebook to Amit Singh, sir. He will circulate among all the participants. And whenever I'll also give my details. Whenever you have any doubt, you can always reach me. So all of you opened a new notebook. Can you please confirm?
Sir.
Can participants please confirm you have opened a new notebook?
Yes, sir. Yes, sir.
Import, as I told you, the first standard commands: import pandas as PD, import numpy as NP, import matplotlib dot pyplot as PLT, percentage matplotlib in line. These are the standard commands you need to run whenever you open a Python Jupyter notebook. These packages have to be imported. These libraries have to be imported. Okay, I'm pasting them again in the chat window for participants who want them. So, okay. Now, let us look at something called recurrent neural networks. Recurrent neural networks. Did you cover? I think the theoretical has been covered, right? Recurrent neural networks. So recurrent neural network. Not that clear. Let me see the. So recurrent neural networks will have something called forget gate. That is the difference between, it is also sequential neural network. Recurrent neural networks are also sequential neural networks. That means one after the other you will have layers. But there is something called forget gate within the recurrent neural networks. Recurrent neural networks will have something called forget gate. That means if the input values are not significant, it will automatically, LSTM. LSTM will have forget gate, not recurrent neural networks. See, LSTM is a type of neural network that this is your RNN network, which is a sequential network where it has a loop that goes through various nodes, and then it will pass on the inputs to different nodes, and different nodes will calculate the evaluate the values and give us the final output. Okay. So in a typical recurrent neural network, you will pass the input to the cell will send the output. That is a typical RNN. Now, when you get to your LSTM network, this is the LSTM network where it will have something called forget gate. That means once the model input is done and the input gates are there, once the cell feels the value is not significant, or if it feels it is significant, it will push it into your forget gate, or it will push the values into this forget. So LSTM is a recurrent neural network model which is widely used in time series data prediction. LSTM networks are widely used in time series predictions. That means their utility lies in IoT data also. So LSTM are a type of neural network, that RNN network, that are widely used for time series prediction. Time series means IoT. IoT prediction will be the what we call IoT data is time series data. Now you can see all the equations in this place where you can see what all values are calculated and how the formulas will differ. There are different things in the LSTM network. So this is the LSTM network which is widely used. So this is how it will calculate the various components of the neural network. ZT is sigma W weight into Z into HT minus XT. So the data enters to this. It will calculate the ZT first, then it will calculate RT. RT is your forget gate. If it is going through, it will go to HT, which is your tan H activation. From tan H activation, it will go to your HT, which is your this thing, what you call activation. So this is a model which is widely used in IoT and time series forecasting. LSTM can also be used in natural language processing, but there are better models in natural language processing than LSTM. You can use LSTM in natural language processing also, sir, but there are some better models than LSTM in natural language processing. So this is your basic what you call LSTM, standard LSTM structural model, where Z is equal to, this is the calculation methodology it uses for various, and finally it will pass the value. So these are the things. I will send you an article where you have the actual numerical calculation also. Since we have paucity of time, I'm not going through the TD. Okay, so we'll just implement it, or we will implement it on our time series data. Will that be okay? I think you have gone through LSTM theory also, right?
Some basics have been covered.
So I think we have time till 1:30 only. So let us build a model. If time permits, I will talk about the thing. First, let us implement. Okay, that way it will be easy for you to. So LSTM is a type of recurrent neural network. It is used predominantly for time series. See, audio classification, you have to use signal processing algorithms. LSTM also works on audio classification. See, LSTM works with all types of data. It also works in our previous image processing also. But it all depends on the accuracy levels. How accurately, how you do this. So LSTM can be implemented on audio classification also, but we have to check for the accuracy levels on how well the model is running. That is the critical part here. Okay, so there are, I think, new versions of deep neural networks which are there for audio. Okay, so let me implement the LSTM first. I'll implement this LSTM data. LSTM model on a time series data. For our convenience, let us take stock market data. Okay. From pandas underscore data reader, import data. From pandas underscore data reader, import data. Okay. So this pandas data reader will help you to scrape data from web sources, particularly financial data. Okay. So let us get the Sensex data. Sensex is equal to data dot get underscore. See, it can download data from various sources. So we will download the data from Yahoo. Get underscore data underscore Yahoo, open bracket, single quotes, inverted V, which is your numerical case C. Shift plus numerical case 6, you will see the inverted V. You are downloading the data of Sensex. Sensex is equal to data dot get underscore data underscore Yahoo, open bracket, single quotes, inverted V is your shift plus numerical key 6, and DSCSN is the name of the Sensex data on Yahoo Finance. Yahoo Finance sticker. Okay, so what data we got? Sensex dot head. We got the data as this. We got the opening data, high data, low data, open data, close data, and volume and other adjusted close price. Adjusted close. So we have these columns of data: high, low, open, close, and adjusted close. These are the data points which are imported once you import the data. Okay. Now, if among all this data, we need close price. We will take only close price because close price is considered to be the stationary data. Because in time series analysis, the data must be stationary. So for time series or IoT analysis, if you are using time series model for data must be stationary. Stationary means there should not be significant changes in that data. So generally in stock price data, we consider close price as our what we call stationary data. Okay. So train underscore set is equal to Sensex dot ilog square bracket colon comma 3 dot values. So what we are getting here is we are choosing the column called close price. So train underscore set is an array. Is an array of close prices. Train underscore set is the array of close prices. We have selected the close price data as our analysis data. And what is the length of this data? We also need to know length of the train underscore set. The length of this data is 1230 rows. There are 1230 rows of data. There are 1230 rows of our data available. Okay. All of you got the data? Okay. Now we will import the required functions for running our LSTM. We will import the required functions from sklearn dot preprocessing import min max scaler. Import min max scaler from Keras dot models import sequential from Keras dot layers import dense. Dense is for building the neural network. From Keras dot layers import LSTM, long short term memory network. From Keras dot layers import drop out. Import drop out. So these are the functions we require for building a neural network from scratch for our time series data. So min-max scaler, sequential, dense, LSTM, and dropout. These are the things we need for building our neural network, LSTM network.
Hello.
Yes, please.
Sir, how should I know that which things I should import for LSTM or anything? If I have my own problem, then how should I know, sir? From experience or from any?
First thing, if you want to build a neural network, right? Build neural network from scratch, right? You are building a neural network from scratch. What you require? First, you require sequential. First, you need sequential, right? Because all what is required is first you need sequential, because all neural networks are sequential model. Second, you need to decide whether you want to do convolution 2D or you want to do LSTM, or you can see in Keras there are a lot of these are your models, right? Convolution 2D, LSTM, or let me show Keras. What are all there in Keras? Keras neural network. Okay. So in the deep learning API of Keras, you have everything. So let us say what you call Keras ecosystem API code examples. See here, you will have different things here. What all you need? You need the code examples, network, everything is available in here. For computer vision, natural languageization, structure process, and time series. Let us say for time series data, you can use autoencoder, anomaly detection. You have this autoencoder for anomaly detection, or you can do a classification algorithm. You can from scratch, you can do classification algorithm. So for classification algorithm, what you required is once you standardize the data, build a model. Again, convolution, ReLU is what you are using for classification of time series data. If you want to forecast for prediction for time series data, what you need is you can see here what all functions you need. One second. See, LSTM. Then, once you, one second, let me charge up my you will see a lot of code examples available on Keras site. Based on that, you can choose your models. And there is your, then you have to look at your literature reviews also, right? Some literature reviews will give you what type of data to use and all. So you can say LSTM or RNN. You need what based on your requirement. You might need max pooling or some sort of pooling you need if it is an image classification, or else if you are doing, then you have need dense for building neural networks. Dense is for building the neural network. Building neural network. And for images, you also need pooling, flattening also. You have to ultimately flatten. So you will know what you require for building from scratch from the documentation. For image processing, you will need convolution. When you're using any type of image processing, you need convolution 2D or 3D. You need max pooling. You need flatten. For case of our LSTM network, we have required sequential, LSTM, dense, and dropout. And dropout also is required for things. So for building a basic network, you also need dropout. Okay. So you will come to know, if you have any doubts, refer the documentation. Okay. And literature reviews. The literature reviews will also tell you what type of models are being used. And you will generally, the codes will be available in GitHub. You can get the code from GitHub also. Okay.
Okay, sir. Okay. Thank you, sir.
All right. Now, first, let us transform our data. Like I told you now, in case of neural networks, you need to scale the data, either standard scalar or min-max scalar. So we are using, in this case, min-max scalar. For that to work, we need to convert our train underscore set into a data frame. PD dot data frame train underscore set. Now we will scale it. Train underscore scale. Train underscore scale is equal to SC dot fit underscore transform train underscore set. So we can, using these three commands, we have scaled our data. I'm pasting them in the chat window. First, you have to call the scalar with a short name, then convert your data into from array to a data frame, then convert the data into scale. Min-max scalar will convert it into 0 and 1. Okay, so we got the scaling data now. Now the data is in a scale format. So you can see the data as scaled. See, 0.14. Actually, our data is in 29,000, 30,000 like that, right? It has scaled between 0 and 1. The data has been scaled. Data has been scaled. Now, remember, either you have to do, most of the time we use normalization or min-max scalar in deep learning. Very rarely we use standardized scalars, which is x minus mean by standard deviation, which is your Z score. Okay. Now, we will split our data into x underscore train is equal to null braces, y underscore train is equal to null braces, x underscore train is equal to y underscore train is equal to null braces. For I in range of 60, 1230 colon x dot train dot append, x dot train dot append, train underscore scaled, train underscore scale, square bracket, I minus 60. That means we are taking the last 60 observations to predict the next observation. We are building a model where we are using the last 60 observations to predict the next observation. So y dot train dot append train underscore scale square bracket I comma 0. So we are saying use the previous 60 data points to forecast the 61st data point. Now we will convert it into arrays. X underscore train comma y underscore train is equal to np dot array numpy array x underscore train comma np dot array y underscore train. So we have converted the data into arrays. Okay. X underscore train is equal to np dot reshape. We are reshaping the data. X underscore train comma open bracket x underscore train dot shape square bracket 0 comma x underscore train dot shape square bracket 1 comma 1. So we are using this whole process to reshape our data. X is not defined. Where is X? Okay, X underscore train. I use full stop. So this is the code I'm pasting in the chat window so that you can take it from there. For reshaping our data, we are using this process to reshape our data to fit into a LSTM model. We will define our LSTM model. Okay, we will define our LSTM model. Regressor.
To see the array just before this one, you pasted some code to see the array.
Yeah, that is simply say x underscore train.
Huh?
X underscore train. That's all. You give x underscore train, it will show you the array.
Okay.
Regressor is equal to sequential. Regressor dot add open bracket LSTM open bracket units is equal to 50 comma return underscore sequences is equal to true comma input underscore shape is equal to x underscore train dot shape square bracket 1 comma 1. I'll paste the code in the chat window once I build the model completely. Regressor, regressor dot add dropout we want dropout to be 20%, then regressor dot add. We want another LSTM network, LSTM, open bracket, units is equal to 50, comma, return underscore sequences is equal to true, regressor under dot add, dropout of again 0.2%, dropout of 0.2, then again regressor dot add LSTM units is equal to 50, comma, return underscore sequence is equal to true, then regressor dot add. We will add a dropout layer. Dropout is 0.2. Then again regressor dot add LSTM units is equal to 50. Okay, then regressor dropout regressor dot add dropout, this time again 0.2. Now final layer, we are predicting only single value, right? Regressor dot add dense units is equal to 1. We are predicting the only one outcome, so dense units is equal to 1. Regressor dot summary to see the model. Okay, small error. Sequence underscore sequences is equal to true. What is the problem here? LSTM regressor dot add LSTM units is equal to field. Spelling mistake, huh?
Sir, after units is equal to 50, brace should be removed.
Oh, yeah, thank you. Yeah, so I am pasting the complete model in the chat window. So sequential model, you can see here LSTM 10,400 parameters. So total parameters would be 71,051. Now we'll compile the errors. Regressor dot compile, open bracket, optimizer is equal to Adam, comma, loss is equal to mean squared error, mean underscore squared underscore error. So this is a regression problem. We will compile and mean squared error. Regressor.compile, optimizer is equal to Adam, loss is equal to mean squared error. So now we will fit the model. Regressor.fit x underscore train, comma, y underscore train, comma, epochs is equal to 20, comma, batch underscore size is equal to 32. Okay, let us run the model. So what is the time frame it is taking? ETA is in seconds only, so no problem. ETA is in seconds, so no issues at all. So the model has run, now we can evaluate. So regressor dot evaluate x underscore train comma y underscore train. Where is the training data for evaluation? It is giving a mean square error of 0.002. It is giving a mean square error of 0.002. Actually, what is the mean square error is SC dot inverse transform. This is the mean square error. Oh, sorry.
Hello, sir.
Yes, please.
Sir, when I'm going to GPU, changing to non to GPU, that it is saying that regressor is not defined. But if I
Regressor is
tell
not
again convert it to non, it is taking as a okay.
Just check somewhere, you might have missed a spelling mistake or something. Because regressor we are defining, na, sir.
Yes, sir. But whenever I am converting to non, it is okay. But when I change to GPU, it is not recognizing regressor. Let me check
Because
one
you
more
have to
time.
run from top. Even if you convert it in, once you convert it in GPU, na, you have to run all the commands.
Okay, sir. Yes, sir.
You
Got
have
it.
to run all the commands from top.
Okay, got it, sir. Got it.
Okay? Yeah. GPU, you have to run all the commands. The moment you GPU says, all the existing values will not work. So regressor dot evaluate. This is the code which we got. Now you can predict also. Predicted underscore sensex is equal to regressor dot predict x underscore train. Similarly, predicted underscore sensex is equal to SC dot inverse transform predicted underscore sensex. So we can predict. So let us see what is the actual and the PLT dot figure. PLT dot plot underscore set color is equal to green and label is equal to sunsets. PLT dot plot So this will give us the plot of how our prediction is going along with the actual thing. So once you have predicted the values, you can see the graph, how the actual and the predicted is going on.
Sir, after step number 21, I am getting different answer from than you.
What's step number 21?
Yeah. The final answer
What
I am getting 0.003670.
Okay, no problem, no problem. That's not a major difference.
Okay.
So the predicted model is almost closer to Sensex actual data, but we need to fine tune it even further.
Sir, the Sensex data on several days it is closed. The Sensex is closed. So how we can, because it means the data is not equally spaced.
No, sir, the thing is, weekends are accounted for, sir. Holidays and all will be accounted. That's what we got trading days as 1,230. When you download the data from Yahoo Finance, sir, it will only give the data for trading days. Non-trading days will be left out. That is taken care of in our Yahoo Finance only. In Yahoo Finance, only trading days data is available. For non-trading days, it will jump to the next trading day, or holidays or festivals, whatever is there.
Okay. It means my data, the time series is equally spaced.
Yeah, it is equally spaced. Trading days, based on 252 trading days in a year, or 244 trading days in a year, you can consider it as equally spaced.
Okay. But what will happen if my time series is not unequally spaced?
So unequally spaced, then you have to use two procedures, backfill or forward fill. For whatever the data is missing, right? So if you say unequally specified, that means some points data is missing.
Okay, sir.
Am I right?
Okay.
Sir, unequally spaced means there are two things. One, the data is missing. Second, the time series feature itself is unequally spaced. If I assume data is missing because of which you have seen inequality, you have to fill the missing data with two procedures, backfilling or forward filling. Backfilling means take the previous value and fill it up in the missing space, or you can use forward value to fill up the missing value space. So we have to find out what is the reason for inequality. Can you give me an example where you have this unequal time series?
Suppose if I want to apply these methods to the earthquake prediction.
Which one, sir?
Earthquake prediction.
Earthquake predictions, that's a different data, na, sir. That comes under Poisson distribution. That doesn't come under, see, earthquake data or even rare events data, it comes under Poisson distribution. For Poisson distribution, we have different set of models. Here, linear model assumes normal distribution, sir.
Okay.
Linear
Thank you, sir.
models
And then we will discuss.
Linear models assume normal distribution.
Yes,
if you
sir.
say data
So
or
for the Poisson, we will discuss that what models we can use. We will discuss separately.
Yes, sir. Yes, sir.
So for Poisson also models are there?
They are there, sir. They are there for predicting I'm not remembering exactly. Let me check once.
Okay, sir. Okay. We will discuss later on. I mean, that is
just a second. Let me. So deep learning insurance mortality. I think there are mostly machine learning procedures are used, sir. So time series forecasting using deep learning, there is a one paper in SSRM, you can look at that. What they have used, so they have used naive implementation, so the out structure of the Lee-Carter model can be generated, propose a relative simple convolution network model that can be interpreted as a generalization of Lee-Carter model. So I think convolution neural networks is used, sir, because mortality is a rare event, right? Mortality rates using it's a time series data, but it comes under Poisson data again. So you can use convolution network. You can look at this paper, sir. Time series forecasting of mortality rates using deep learning.
okay.
So all of you got the output?
Yes, sir. We got.
Okay. So I have shown you the LSTM and the CNN. One last thing, Alexnet. You might have heard about transfer learning and Alexnet. I will just give you the code of Alexnet also, which is one of the prominently used transfer learning model. It will just take 2 minutes. We will run it on GPU, so it should take faster thing. Just let me give you the code of Alexnet. That will also help you in terms of understanding how to use pre-trained models. How to use pre-trained models you can use from this Alexnet. Alexnet is a pre-trained developed model by Google. It's a very comprehensive model, which I will give you the code. We'll run it in a new notebook. All of you can close this notebook and open a new notebook, please. So the structure of Alexnet is very complex. Alexnet architecture, you will see this predefined architecture widely used in ImageNet classification. A lot of research people use this Alexnet classification, image classification, deep convolution network. This is the structure of Alexnet, which is a very, very comprehensive structure. It is also a convolution neural network. It is also a convolution neural network. Okay. So this is the ImageNet. For using ImageNet, I've seen a lot of people using this Alexnet. So this is the structure of Alexnet. Very comprehensive structure. All of you activate the GPUs in the new notebook. All of you open the GPUs also in the new notebook. Open a new notebook and also activate the GPU.
Yes, sir. We have to activate GPU. Okay.
Yeah, edit notebook settings and activate the GPU.
Okay, sir.
Because Alexnet cannot be run on normal system. It can be run only on GPU. One epoch takes 11 minutes in normal CPU for Alexnet. 11 minutes is the time it takes for one epoch. So we need GPUs for running Alexnet. It is a convolution network which is widely used in image processing. A lot of researchers use this. I think I've closed my notebook again. So we will import these models. I'm pasting the import models. Let me check once. Notebook, so yeah, GPU. It is GPU activated. So Control C, Control V. I pasted the required packages. Now let me take the random seed. See here, when you set a random seed, your model parameters will not change every time you run. Otherwise, if you don't set a random seed, every time you run the model, because of the random weight assignment, it will change. So let us set the random seed. And now we will start with the, I will copy and paste the Alexnet code completely. It's a very complex code with the different layers and all. So let me just look at the code. Second convolution layer, third convolution layer, fourth convolution layer, fifth convolution layer, then flatten, then 4096 input units, then 4096 input units, batch normalization, dropout, output layer it is softmax. This is the model. Control C, I'll put it in the message window. You can take it. And I will also paste it in my notebook. Control V. This is the Alexnet model. Very, very comprehensive model, which is used by this Alexnet model. Then we will also do the compiler, Alexnet compiler. I'm very sorry, I'm meeting your lunch time. So just sorry, I think it's already 1:30. So
Very interesting, sir. I mean, we take lunch every day. We can miss lunch.
Yes, we can do. We can do.
it will be over, sir, no problem. I'm just putting, this is the new data set, CFAR data set.
Yeah.
We are using the CFAR data set, which is again a new type of data. I'm changing the data again, so that you can have feel of different data sets. CFAR is also a data set. I will show you what is it means. 35,000 images of 32,3 CFAR. Okay, so let me also show you the CFAR code here. Control C, Control V. You can see the CFAR 10 data set. Then once you have the data set, we will do the one-hot encoding of the labels. So this is all same process, downloading the data, then you can see here. Madam, you can see the train and test split code here. This is the train and test code which I am talking about. In the CFAR example, you can do your own train and test sampling. Madam, if you are there, this has your preferred sampling structures code. Okay, this will help you to things. Then your image augmentation, the new thing in train data and data evaluation. So it will play image augmentation, will help you to rotate, spin of the images and all you can do. So image data generator is added to Python to create images or to alter the images in terms of what we call rotating them, reducing the what we call grayscale, or increasing the grayscale, or reducing the noise. All those things can be done using this image generator. It alters the images in terms of rotation, shape, and all those things. And then we will define the parameters. Will be let me also copy them into parameters. Then we'll train the model. On the Alexnet. See here, it is running in seconds. That such complex structure is running in seconds. If you try to run it on your normal system without this GPU, I tested yesterday. It took me for one epoch 11 minutes. 640 seconds. Now it is just running in a matter of seconds. See, 20 seconds it is running. So this is the advantage of the GPUs. Where you can run this data at a very, very fast pace. And CFAR 10 is also a very popular data set in data science. CFAR 10. All the codes are there, ma'am. So these are the CFAR 10 images. So aeroplane.
So train generator code is not there.
Where, sir?
A train generator.
Okay. Sorry, sir. I'll paste it now.
For that mistake is happening. Okay.
Train and image documentation data is not there. Okay. Sorry. This is the image generator. It has to be run before your learning rate annihilator. Before learning rate annihilator, you have to run this generator code. Please. Where is what I missed it? Run it before learning rate annihilator and then continuation of running. So this is the CFAR 10 image classification. airplane, automobile, bird, cat, deer, and dog. These are the images, 35,000 or some images in train data set, 10,000 images in test data set, C for 10.
The last one where we have to put?
Before learning rate annular, sir. Before learning rate, actually what happened was, I forgot it to put it in the chat window. 1 second, let me just tell you. So, you have to put it for learning rate annular. No, after sequential. After sequential, after importing the data. We have this data import now, sir. Keras library for CIFAR data set. After that, you have to do image data augmentation.
Sir?
Yes, please.
Sir, for image data, that Alexnet pre-trained model is very good and we are using that, we can use. But in case of sequential numeric data, can you have such a pre-trained model? Like, can you suggest some, or we have to move from scratch?
LSTM is the best model for sequential numerical data.
Okay.
Any sequential numerical data, LSTM models are preferred. Okay, and nowadays there are new models being developed also. I can send you, just send me an email. My contact details, I'll put it in the chat window. So that
sir.
Email me. Or I also have a YouTube channel. You can look in that channel regularly for any updates.
Okay, sir. Thank you.
Okay.
So,
yes, please. Any doubts you can have, you can ask me now.
which is your YouTube channel?
1 second.
So, which is your YouTube channel?
1 second, ma'am. 1 second, ma'am. I'm pasting it. So this is my channel where you have all the required videos. So what happens is I constantly update them. So you have videos related to NumPy for image processing, related one, quantitative finance, Python programming, Python statistics, Python for machine learning, R for machine learning, natural language processing, all videos are there. These are the sessions which I have conducted. So you have detailed videos with all explanations and codes, everything is available here. So structural equation modeling, time series, yeah, Python for machine learning is there. So you have both classification as well as regression techniques. Black box model, very difficult to understand by. So all the data with
Now we'll go for training.
slightly improved with lip linear theory as well as practical. You should get accurate. Diagnosis.
That is really helpful, sir. Thank you, sir.
So you have everything here. So once it builds the algorithm, it uses the majority voting or the average method. So actual CS. So with code examples, everything will be there. But when you are calculating Gini for regression problem, the mathematical formula is very long. The sequential building of trees, it will take some time. So all the theory as well, practical, both are there. You can look at it videos. All the videos are there. Both for R and Python, all are there. Any other doubts you have, you can ask. This will keep on running for another 5-10 minutes. So you can ask now and then we can end the session so that it can run on your systems while you take your lunch. Any doubts you have, you can ask me now.
Yeah, sir. We have got that CPU and GPU. Now there is one TPU also available. So can you tell me what
tensor processing?
Yeah.
TPU is your tensor processing unit. Now what happens is sometimes people use tensor coding directly. Actually, Keras is again tensor based only, but you can use tensor based coding directly. So some people are using, if you want to create your own thing, this TensorFlow based coding is there. PyTorch and all are coming now. PyTorch is again a version of TensorFlow only, which is used for medical diagnostics and all those purposes. So you can use this TensorFlow based coding, and then when you are using this TensorFlow based coding, you can use TPUs, that tensor processing units. We call them as tensor processing units. They are assumed to be comparatively better than your GPUs. But for my personal experience, I have not seen much of a difference.
Okay.
Okay. So take, for example, this one, deep fake recognition. If you are looking at deep fake recognition, we use this adversarial networks, GANs. GAN networks. So this is very interesting. I have the code. If you want, I will send it to you also. So these GANs are very widely developed, and now they are being used by Facebook and WhatsApp to identify fake news and all. So adversarial networks will create similar data to the fake data, and then it will compare that with the actual data and finds out the fake. So you have this in TensorFlow. This is a DC GAN thing, deep convolution general adversarial network using TensorFlow coding. Now, when you are using TensorFlow coding, it's better to use TPUs. Some people say, but I have not seen much of a difference. TPUs and GPUs are performing well, where you have all the codes available in the TensorFlow documentation, the generator model, discriminator model, and then the optimizers, everything. And also, you can also use Cycle GAN. There are different teams which are there. Deep Dream, the new one which is came now, Deep Dream, which is again related to image processing. So these are there. So always please check on what we call TensorFlow documentation, which I will paste here. This TensorFlow documentation has all the things which you require.
Okay.
So it's the best option. Okay, but always use GPUs. If you find GPUs are not working that much, then you go to TPUs.
Okay.
Don't directly use TPUs. GPUs are far better, because what happens is when you use GPUs and TPUs on a 4 GB RAM, it will cause some problem on your other functions of your laptop to slow down.
Yes, sir.
That is why preferably use GPUs. If GPUs are not working, then go to TPUs. And what we have done now, sir, Alexnet. Alexnet is a predefined model which I am using for CFAR dataset. So in transfer learning, you get the existing model codes. You alter it according to your requirement and you change the data input and then you run them. So transfer learning is using existing models, deep learning models on your data sets or the data which you have created.
Yes.
So that is the process of transfer learning. Now there's one more thing called reinforcement learning. Reinforcement learning is a different concept which is also based on neural networks.
Yes.
So reinforcement learning is also there, which is also very, very interesting. So that is also used in neural networks.
Okay.
Autoencoders for detecting anomalies and frauds. So you have all the codes available with very simplistic things. Again, this is on Fashion MNIST only, autoencoders. You can run it on all your data.
Okay.
And you can see how the accuracy improves. So,
sir?
Yes, please. Yeah.
Sir, where we can get some good coding data or coding part for reinforcement learning?
See, for reinforcement learning, I think Python has a good repository. I'll just give you the link in a second. Participants who do not have any doubts, you can leave. I'm sorry, I'm taking our lunch time. Or if you have doubts, you can stay back. Okay. I have a website where it should give you the things. So I think there is not a standard source, but you can find it on internet very easily, the codes in GitHub.
Okay, sir.
Okay. I think this is the one. OpenAI something is there. Jim Atari, which will give you the this thing. The package is OpenAI. I think this one only. Pip install Jim Atari. The package and OpenAI Jim. So this is the Jim toolkit, which is there. I think this is a Python-based one only. Import Jim. Yeah, you can import this Jim library. For reinforcement tasks, the library is Jim. You can copy paste the link.
Sir, can you do reinforcement learning coding in the Google Colab notebooks?
Yeah, you can do it. You can do it.
Okay.
You can do it. You can see the codes on GitHub also. They preferably it's on Colab only.
That means we have to import whatever the packages have, and then we can proceed with in Google Colab.
See, if it is not available, let me check once. Let me check, because Google Colab comes with AI functionality also. Let me check once. Just type. No. If you for you the model is running, right?
Sir, running.
No, don't do anything. Import Jim. Jim is there, sir. You don't need to import. It is there in what you call Google Colab. So you can directly start reinforcement learning from here only. Jim is there in Collaboratory. See?
Yes, sir.
Jim is there. You can directly start working from Google Collaboratory. So you don't need to import. If you are using Google Collaboratory, it is already there. So any simple function you want to run, you can run from here. And the examples and documents are there. This thing. You can run it from here. So Jim is there in AI. Jim is for AI only. It is there in Python Collaboratory, not in base Python.
Okay. So today, It was a very interesting talk, especially from since morning. We all are learning a lot of things in Python, and in fact, we should have scheduled more sessions to understand more models and more. Lot of things are there in the machine learning and AI. And today, due to limited sessions, we could able to finish 2 or 3 models only. But next time, let's hope next time we will have a more technical session on Python, and more participants, more researchers will be benefited with the help of our learning, and especially the demonstration through Google Colab. It will help us a lot. So with this note, I would like to thank Rajesh Prabhakarji for delivering a talk and strengthening the technical capability of the participants. Thank you. Thank you, Prabhakarji. Let's hope we will meet again next time. Okay,
Sure, sir.
thank you.
Thank you.
All the
Thank you all
participants are requested to be back after quick lunch at 2:20 or 2:25, so that we will be able to give 5 minutes break before assessment. Thank you. Thank you all.
Thank you very much.
Thank you. Thank you all for participating. You can always reach on my email ID and mobile. Thank you.
Yes,
all.
yes.
This conference